Hello mathematicians! In today's video, we're going to solve quadratic applications. All that means is that we're going to be solving word problems that involve quadratic equations. On example 1, the square of a number minus twice the number is 48. Find the number. So let's just break this up into all of its different parts. The first thing that I read is the square of a number. Now, I do not know what the number is. So I'm going to call the number x. So that means that the square of a number is x squared. Minus means we're subtracting twice the number. Well, if the number is x, then twice x means that it's 2x. So x squared minus 2x means equals 48. So this is our quadratic equation. Remember, it's quadratic because our highest exponent is 2. Now, we've learned 4 different methods for solving quadratic equations: factoring, taking square roots, completing the square, and the quadratic formula. You can use whatever method that you would like here to solve. The only method that wouldn't work is taking square roots because we have a b term here. So we could either solve by factoring or solve by quadratic formula or completing the square, whichever you prefer. I'm going to solve this one by factoring. To solve by factoring, I need to make this equal 0. So to solve by factoring, it must equal 0. So to do that, I'm going to subtract 48 on both sides. And I'll have x squared minus 2x minus 48 equals 0. Now remember, the quadratic formula would work every time. So if you didn't want to see if it was factorable, you could always solve by factoring and try it that way. So, not solve by factoring, solve by quadratic formula and do it that way. We are solving by factoring because I know that this one is factorable. Your first step with factoring is to always look for a GCF. And in this case, I do not have one. So my GCF is none. So then I'm going to go straight to the area model. First term goes in the first box. Last term goes in the last box. I'm looking for 2 numbers that multiply to negative 48 and that add to negative 2. And those 2 numbers are, let me use red, negative 8 and positive 6. Negative 8 times 6 is negative 48, and negative 8 plus 6 is negative 2. Now remember, because my middle term has an x, both of these are going to get an x. Now that I have filled in my box, I can go ahead and find the GCF of each row and of each column. The greatest common factor of my top row is x. The greatest common factor of my bottom row is 6. The greatest common factor of the left side is x. And the greatest common factor of the right side is negative 8. So my factors are x plus 6 times x minus 8 is equal to 0. So from here, I can use the principle of zero products to solve. So I'll either have x plus 6 equals 0 or x minus 8 equals 0. So now I'm just going to solve each equation. To undo addition, I'll do subtraction and get x equals negative 6. To undo subtraction, I'll do addition and get x equals positive 8. So the numbers are negative 6 and positive 8. Both of these numbers will work. If you do the square of a number with negative 6, so the square of negative 6 is 36 minus twice the number. So negative 6 times 2 is negative 12. So 36 minus negative 12 is 36 plus 12, which is 48. If you do 8, the square of 8 is 64 minus twice 8. So 64 minus 16, that is also 48. So both of those numbers work here. Let's go ahead and try example 2. On example 2, the width of a rectangle is 5 feet less than the length. The area is 24 square feet. Find the dimensions. So on this one, it says the width of a rectangle. So the first thing I'm going to do is draw a rectangle. With a rectangle, we know that this side will be the same as this side, and this side will be the same as this side. So remember, these marks that I've just drawn are congruency marks. Because each of these only have one, they mean that these are the same length. And because these sides have two, it means that these sides are the same length. So let's go back to what it says in the problem. The width of a rectangle is 5 feet less than the length. I don't know what the length is. So because I don't know what the length is, I'm going to go ahead and call that x. If the width is 5 feet less than the length, then it's the side of the length of the side minus 5. Right? So for example, if this was 20 and this was 5 feet less, then this would be 20 minus 5. So you'd have 20 and 15. So that's what that's saying. The next part says the area is 24 square feet. Now we know that the area of a rectangle is length times width. So in this problem, that's going to be x times x minus 5, my length times my width. And that's going to equal my total area of 24 square feet. The first thing I need to do with this equation is I need to distribute. X times x is x squared. X times negative 5 is negative 5x. So now I have x squared minus 5x equals 24. Now you can choose to solve this equation either by factoring or by quadratic formula, whichever you prefer. This one looks like it's probably going to be factorable, so I'm going to choose to solve by factoring. And again, if I choose to solve by factoring, I need one side to equal 0 to be able to solve that way. And so to make one side equal 0, I'm going to go ahead and just subtract 24 on both sides and get x squared minus 5x minus 24 is equal to 0. So from here, I can go ahead and solve by using the area model. Your first step when factoring is to always look for a GCF, and in this case, there is not one. So then I'm going to go straight to the box method. First term goes in the first box, last term goes in the last box. Remember, you always got to multiply your first number by your last number. 1 times negative 24 is negative 24. So here I'm looking for factors of negative 24 that add to my middle term of negative 5. Well, those numbers are, let's see, negative 8 and positive 3. Negative 8 times 3 is negative 24, and negative 8 plus 3 is negative 5. So these are going to be the numbers that go in the empty spaces of my area model. So now I can find the GCF of each row and of each column. The GCF of the top row is x. The GCF of the bottom row is 3. The GCF of the left side is x. And the GCF of the right side is negative 8. So I'm going to have x plus 3 times x minus 8 is equal to 0. So now I can use the principle of zero products to solve. So I'll have x plus 3 is equal to 0 and x minus 8 is equal to 0. So I can just solve each equation. And so to undo addition, I'll do subtraction and get x equals negative 3. To undo subtraction, I'll do addition and get x is equal to 8. Now we were asked to find the dimensions. Well, let's think about what our answers mean. This means that the length of our rectangle is negative 3 feet. Can we have a negative length? No, that wouldn't make sense in the real world. You could not ask somebody to make you a table that was negative 3 feet long. The table would not exist. So because this is a negative length, it's not going to work in the context of this problem. So we can't have negative length. We can have a table that is 8 feet long. That does make sense. So x is going to be 8 feet. And then our width will be 8 minus 5, which is 3 feet. So our dimensions are 8 feet by 3 feet. This is our answer. On our last example, it says an object is launched directed upwards 64 feet per second, let's just say feet per second there, from a platform 80 feet high. This can be modeled by the equation S of t is equal to negative 16t squared plus 64t plus 80. When will the object hit the ground? So this is the equation that we're using. And it wants to know when the object will hit the ground. So this will be when the height is 0. The height in this problem is S of t. So that means our equation will be 0 equals negative 16t squared plus 64t plus 80. So now we have a quadratic equation that we can solve. It equals 0, so we could try to solve by factoring, or we could use a quadratic formula, whichever you prefer. Since I have some larger number here, I'm not going to try to factor it. I'm just going to use a quadratic formula because I know that's going to work every time. So if I use the quadratic formula in this problem, A is negative 16, B is 64, and C is 80. So I'm solving for time, so I'll have t equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So let's go ahead and try to simplify this a little bit. So I have negative 64 out in front. And next, I'm going to go ahead and calculate this discriminant. So to do that, I'm going to plug this into my calculator. So I'm going to use the Desmos calculator here. And so we have in parentheses, I'm going to type it just the way I have it. So I'm going to have, what was it again? Let's see. 64 squared minus 4 times a, which was negative 16, times c, which I think was 80. Yep. Notice how I put everything in parentheses. And when we do that, we get 9,216. And in my denominator, 2 times negative 16 is negative 32. Now, this is a real-world problem. So when we talk about seconds, we don't talk about the square root of seconds. Like you wouldn't say to your friend, oh, I can run from here to there in the square root of 34 seconds. Right? You would say, I can run from here to there in, I don't know, like 6.1 seconds. So we're actually going to go ahead and calculate the square root. You don't have to worry about simplifying the radical with the word problems. We're just going to go ahead and identify what that square root is. So I'm going to bring over my negative 64 and my negative 32. And what I'm going to do now is I'm just going to go ahead and calculate this square root. So I'm going to go back over to Desmos. And I'm going to find, let me enter. There we go. And I'm going to find the square root of that problem. And when we do that, we get 96. So that's good because that was a perfect square. $96, yep. All right, so from here I have two problems. My two problems are, I have negative 64 plus 96 over negative 32. And I have negative 64 minus 96 over negative 32. Again, I have one problem for my plus sign, and I have the other problem for the minus sign. So that's where the two problems come from. So when I do this, negative 64 plus 96. So negative 64 plus 96 equals 32. Divided by negative 32 is negative 1. On this one, negative 64 minus 96 is negative 160, or negative 160. Divided by negative 32 is 5. So let's think about what we're talking about. It says, when will the object hit the ground? So our units are in seconds. I know that from here. And so let's think about what seconds mean. Can something take negative 1 second? If you throw something in the air, will it hit the ground after negative 1 second? No, we can't have negative time. And so this option does not work for us. Can something hit the ground after 5 seconds? Yeah. So our answer is that the object will hit the ground after 5 seconds.